Welcome to an in-depth look at API hooking, a sophisticated technique widely used in cybersecurity for legitimate purposes like software debugging and performance monitoring, as well as for malicious stealth execution by attackers aiming to evade detection mechanisms. At its core, API hooking involves intercepting and modifying the behavior of application programming interface calls made by applications to the operating system, allowing for custom code execution in place of standard functions. This powerful method enables an attacker to redirect a program's intended function calls to their own malicious code, often without the original program or its security tools ever detecting the alteration. Consider a legitimate application, such as a word processor, attempting to write sensitive user data to a file using a standard Windows API call like write file. Without any hooking in place, this API call would proceed directly and unimpeded to the operating system's kernel, where it would perform the requested file write action as intended. However, with API hooking implemented, malicious code can insert itself seamlessly into this process, positioning itself as a transparent intermediary between the application and the system. When the application initiates its API call, the hook immediately intercepts it before it can reach the legitimate system function, giving the attacker full control at that point. The malicious code can then thoroughly inspect the call's parameters, modify them as needed, or even completely block the original API call to prevent the intended action. For instance, it could subtly change the file path from the legitimate location to a hidden directory controlled by the attacker or alter the data contents before allowing it to be written. This interception technique allows attackers to achieve highly stealthy execution, effectively hiding their malicious activities from antivirus software, endpoint detection tools, and system administrators. Attackers might employ it to inject additional malware payloads, silently steal sensitive user information like credentials, or maintain long-term persistence on a compromised system. Detecting API hooking presents significant challenges for defenders, as the malicious code is designed to closely mimic the behavior of legitimate system components and processes. Advanced endpoint detection and response solutions, commonly known as EDR tools from vendors like CrowdStrike or Microsoft Defender, are specifically engineered to identify these subtle hooking deviations. These EDR systems monitor API calls at a low kernel level, vigilantly scanning for unusual call sequences, timing anomalies, or unexpected parameter modifications that signal hooking. Understanding the intricacies of API hooking is absolutely crucial for both offensive security researchers and defensive cybersecurity professionals working to protect systems. It underscores the critical need for implementing robust security practices, such as least privilege principles, and maintaining continuous, real-time monitoring of system and API behaviors. By thoroughly recognizing how these advanced hooking techniques operate, cybersecurity teams can develop more effective strategies to defend against sophisticated, stealthy threats in the wild. Thank you for joining us in this detailed exploration of the intricate world of API hooking and its profound implications for achieving stealth execution in modern cyber attacks.